Hello students, good morning to everyone. Today I am going to discuss about the concept is called surface chemistry. In the surface chemistry I am going to discuss some important terms, definitions, mechanisms also will be there. Let's start our discussion. Before I am going to move on the surface chemistry chapter, first you have no idea about the what are the things are not there in the chapter. For this academic year, what are the topics are deleted. First you remember emulsion is deleted, catalyst is deleted, homogeneous catalyst, heterogeneous catalyst is deleted. Activation energy, selectivity of catalyst also deleted. Enzymes also deleted only. The topic is called enzymes also will be deleted only. And just move on to our concept is let's move on to our concept. Today I'm going to discuss about the some important things. What is adsorption? What is the mechanism of absorption also, types of solutions, what is absorption isotherm, classification of colloidal solution, everything I am going to discuss in detail today. Let's move on to the surface chemistry. Some basic terms will be there. These terms will be repeated regularly. You must be aware of these terms. So let's start our idea about some basic terms. In the basic terms, first you remember adsorption. Add, nothing but adding of something is. What happened the adsorption? But the phenomenon of accumulation of molecule on the surface. This is my molecule is there, no? Above this molecular surface, something is coming and attaching. Something is getting, like a powder is adding to your face. It's nothing but adsorption. Let's see something. Remember you can see what is adsorption. But adsorption is the surface phenomena. Accumulation of the molecule on the surface of the any solid. What is absorption? The molecules are spread inside of the thing. Okay, in the inside substance, the molecule spreads inside. They are not in the outside only. And you can say sorption at the birthday, both absorption takes place simultaneously, then the word is called as sorption. The word is called as sorption. And you can see the gas molecules are there now. You can see very clear the gas molecule is called as a adsorbate. The gas molecule, you can see clearly this is my, suppose this is my solid. Suppose this is my solid and this is my gas. The material is called as a adsorbate. This is called adsorbent. The gas molecule is called as a adsorbate. You see, the solid is called absorbent, which provides surface area for any process. The gas, which is adsorbent. Solid is called adsorbent only, and gas is called absorbate only. Solid is called absorbent. Remember, this is solid. Suppose this consists charcoal. Charcoal is called as absorbent. Gas is called absorbate only. Both absorption takes place simultaneously. This is called as a sorption. Let's see, in the absorption you can see that there are two types of absorption possible. One is gas molecules are absorbed by the physical forces, physical absorption, by the chemical forces, chemical absorption. During the physical absorption, what happens there? Van der Waals forces will be exist. Van der Waals force is the weak force. Suppose I have to take one material, one solid is there, no? Above the solid gas molecule, they are coming and they are attaching here. The material which provides surface area is called adsorbent. This gas molecule is called adsorbate. So what happens there? You can see that gas molecule attached to the metallic solid surface area, any metallic surface area, by the Van der Waals force of attraction. So it is a very weak force of attraction. Next you can see coming to the chemical absorption, there is chemical bonds are there. The bonds will be strong chemical bonds are there. The strong chemical bonds happen. In the physical absorption is not specific in nature, not specific, irreversible. You can see clearly what happens in the physical absorption. There are the multiple layers will possible. One layer is here, one more layer is there, and one more layer is there. So what are the multiple layers are possible. But you can see in the chemical absorption, you can see the unilayer, the atom, the molecules are attached in a proper manner. Okay. During this process, whenever the gas molecule are added to the metallic surface area, whatever may be, they will lose some amount of energy. Why? Because means delta S value is decreasing and delta H value is decreasing. How much amount of energy released? 20 to 40 kilojoules of energy liberated when gas molecules are added on the surface area. In the chemical absorption, see the amount of energy is 80 to 240. There is huge amount will be there. Huge amount is there, no? Because of this huge amount, you can see the more energy less stable, less energy more stable. Because these molecules are giving the more amount of energy. It means it becomes less energy containing molecules, so it becomes more stable. What happens? They remember physical absorption first. What happens? With the increasing of temperature, it decreases. You see what happens? The graph also they have given very clearly, like this graph will be there. No, in the physical absorption will decrease with increasing of the temperature. Adsorption. This is that is adsorption. In the chemical absorption, what happens there? Now, initially increases and then decreases. This is called as the saturation point. Saturation point. So that's the name of it. The next one is the multimolecular layers will form. Already mentioned the point is the multimolecular layer forms. Here the unimolecular layer forms. No activation energy is required. It does not require any activation energy, but chemical absorption requires the activation energy. Activation energy. So let's move on to the Gibbs energy which is involved in this process. You can see when you know the Gibbs energy nothing but delta G is equal to delta H minus T delta S. Delta G stands for the change in the Gibbs energy, change in the enthalpy, change in the entropy. Gas molecules are attaching on the solid surface area, so automatically delta S value will be decreases. Whenever delta S value decreases, what happens here? The delta S become to the negative, and also this process exothermic process, delta H value also negative. But what's the both are become negative, delta G become positive. Why this reaction spontaneous means delta H value making as a driving force. The value is what happened there now. This value is making more negative and makes a driving force. What happened there now? That reason why it makes reactions are spontaneous. Reactions are spontaneous. So automatically delta G also become negative. So if any chemical reaction must be happen, the delta G value must be negative. Delta G value is positive. That reaction is called as a non-spontaneous reaction. Non-spontaneous. Let's see the next one more point is there now. One point arises for everyone is there now. Why gas molecule are adsorbing on surface area? Because of unequal forces. Let's see one molecule in the bottom. There all sides are some other molecules are there. The total force will be nullified. But what happened in this case? What happened there? These molecules are the force of attraction in the bottom and side. But what happened there? In the upper side, there is no force of attraction that exists. What happened there? In this area, the molecules start attracting the gas molecule. That reason we can able to see the adsorption. Okay, adsorption only. Let's see one more point. Remember let's see you can see the gas molecule absorbing on the surface only. Simple one point is adsorbate. See the adsorbate nothing but chalk piece. Adsorb nothing but board. I would say that the material which provides surface area for the absorption is called absorbent one. Chalk piece is called adsorbate. The process both is called as a adsorption. Both are combined together called as a absorption. Okay, both happen. Let's see one more point. Remember the one more idea is there no. The difference between the absorption already I mentioned very clear is there no. What in the adsorption the particles are uniformly distributed throughout the body. In the absorption the particles are spread and what happened there and surface area. You can see very clearly this is absorption. This is the accumulation of molecule on surface area. Adsorption. What is absorption here? The molecules are spread inside here. The molecules are goes inside. Absorption is the bulk phenomena. Adsorption is the surface phenomena. You can able to see anything is coming on surface area only. They want to go inside. Occurs uniform rate. Absorption occurs uniform rate. There is no increasing, decreasing only. But what happened there? Adsorption initially increases then decreases. Like silica gel is there, no dry silica gel, it absorbs more amount of water, so and decreases. I am saying absorption with respect to absorption only. This is a slow process, it takes much more time, but it is a fast process. Adsorption is a spontaneous process. Spontaneous. It occurs very high speed only. Let's move to some basic ideas. Then you can see very clearly. I have taken the one actually by my ink color bottle. When I place the cloth will be absorb the water. It's called as absorption. Absorption. Okay, no? The process of removing of the absorbent, the process of removing of the gas molecule is there. No, the process of removing of the gas molecule is called as a desorption. Okay, desorption. Deabsorption also you can call, no problem. Desorption, it is called as a desorption, the removing of the gas molecule from the surface. Desorption. Let's see the types of absorption is there here. I mentioned already is, physical absorption and chemical absorption. What is the physical absorption? The absorption is happen because of the physical forces. You see what happened there, here this is a gas molecule, they are not attaching to each other. No? What happened there, this is my metallic surface, metallic solid, anything solid. The molecules are adding by the van der Waals forces in the physical absorption. There is a van der Waals forces. In the chemical absorption, there is a covalent bonds only. You know very well van der Waals force are nothing but a very weak forces. Is a strong force of attraction. And you can see physical absorption, there is no specific nature. But chemical absorptions are highly specific. Physical absorption does not depend upon the nature of the gas. All gas can undergo attraction, but here depend upon the nature of the gas. Physical absorption is reversible in nature. Chemical absorption is irreversible in the nature. Delta H value, you can see that delta H value is equal to negative for the physical absorption. The amount of energy is 20 to 40 kilojoules. In the chemical absorption is also is a delta exothermic reaction, delta H value is minus 80 to 240 kilojoules per mole. So this idea about the physical absorption and chemical absorption. Next one is absorption isotherm. What is isotherm, students? Remember isotherm is a standard temperature. So absorption happened at standard temperature. Let's see what happened there. Here absorption happened. Here X stands. What is X? But a mass of the adsorbent. You can take the mass of the gas. What happened? The M stands for mass of the adsorbent. But it has a solid. K and N value. You can see K stands for constant. N value also one of the constant of the depend upon the nature of the gas. P stands for pressure. What they mention is there the 1 by N value. You see the 1 by N value lies in between the 0 and 1. Suppose you can see clearly x by m is equal to K into P to the power of 1 by N value is equal to 0 means at high pressure x by m become to constant. It means no more gas can be absorbed. When you take the low pressure, if you just take low pressure, x by m value is equal to K power P to the power of N. It means that if you increase the pressure, more amount of gas can be absorbed at the low pressure, not in the high pressure. This is given at the different temperature. You can see very clearly whenever temperature increases, the amount of gas decreasing also, amount of gas absorbed also decreases. You see here this much amount of gas absorbed at low temperature, but here this much amount of gas will absorb. The amount of gas absorption also decreases with increasing of the temperature. Can I say adsorption inversely proportional to temperature. Okay, now next one, you remember the most important thing is called as a colloidal solutions. Colloidal solutions only. In the colloidal solutions, what happens? They remember the solutions are classified in 3 types: true solutions, colloidal solutions, suspension. This value is up to 1000, here more than 1000. So what happened there? You remember colloidal solution is about a heterogeneous mixture. Heterogeneous mixture. It's a mixture, remember mixture. It's containing of the 2 components are there. One component is called as a dispersion phase. Second one is called as a dispersion medium. Dispersion medium. Okay, no? Dispersion medium is larger quantity. Dispersion phase dispersion means smaller phase. Dispersion phase, smaller quantity. Okay, no? Let's see the more details about this one. Is that, remember, you can see one example at the bottom. Milk is made up of the fat plus water. If water is more, so it is acting as a dispersion medium. Your fat acting as a dispersion phase. They both combine, they put together form a colloidal solutions. Colloidal solution, here is the word you have to remember. 2 terms are there now: dispersion phase and dispersion medium. The colloids are further classified. What happened there? Based on their remember the colloids of other class based on their physical state, based on their nature of interaction between the dispersion phase and dispersion medium, type of the dispersion particles are there. Salts. What is salts? But paint, you consider paint is made up of the, you can just consider the liquid, some solid they will dissolve, some color solid they will dissolve in the liquid only. Because paint, but salt. You can see the cheese is gels. You can see the gels. What happened there? Solid contains small amount of the water. Here solid is nothing but a dispersion medium. Okay, solid is dispersion medium. Water is dispersion phase. Emulsion also called as a liquid. Dispersion phase also liquid. Dispersion medium also liquid. It's called emulsions only. Let's see, the idea is there here, the types of the colloidal solution. But you can see very clearly, ruby is there, smoke is there, milk is there, paint will be there, okay, no, pumic stone will be there, ice cream is there, fog will be there, gel will be there. All comes under category of the colloidal solution. How we are going to categorize here? The suppose dispersion phase, dispersion medium, both are the solid. At that case, they can call as a solid sol. Example is ruby glass. Dispersion phase is solid, dispersion medium liquid is called as a sol, solid in the liquid. Example nothing but paints. Dispersion phase is a solid, dispersion medium is a gas. Remember now, in the air dust particles are there, it's called as a aerosol. Remember, liquid in the gas also called aerosol, solid in the gas also called aerosol. But remember, gas never form a colloidal solution. Next, remember the liquid in the solid, it is called gel only, it is called jellies. Liquid solutions called as a emulsion. Example nothing but milk. Gas in the liquid, already mentioned, is aerosol. Gas in the solid some gas molecules are, it's called as a pumic stone, this is called pumic stones. Okay, na? Gas in the liquid, what is gas in the liquid? What is the aerated water? Aerated water. You can say the cool drink. Okay, no? These are nothing but types of the colloidal. There are the 8 types of colloidal solutions are there. Okay, no? Let's move on to our discussion of the, but remember is there here the based on their interaction between the dispersion phase and dispersion medium. Dispersion phase and dispersion medium. The interactions are very good. Nothing but remember no, lyophilic solution, lyophobic solution. Lyophilic solution is the, but I can suppose I have taken the 2 components like a milk and water. When I add together, they make a standard solution. Lyophilic solution, if you add how much amount of water, they can't be separated. Liquid loving solutions are called as a lyophilic solution. What happens is this, I can able to prepare the colloidal solution, I can able to separate the colloidal solution into dispersion phase and dispersion medium. Both are possible. Do not precipitate. Have you seen any time for fat particles at the bottom of this one? No. And easily separated. Example nothing but take gum, gelatin, like this one. Lyophobic. Phobia means fear. It nothing but you can see they both mix properly, and but they won't make a proper colloidal solution. What happens there? Suppose I am just taking one metallic. I have taken metal is then when vaporized become colloidal solution. These colloidal solutions once you prepare means irreversible. We cannot reverse it. We cannot separate them into dispersion phase and dispersion medium. Not possible. Unstable, they need the special chemicals to make the stability. And quickly precipitated. We will add something. Suppose I have taken one colloidal solution. This is my colloidal solution. During the colloidal solution, what the particles are equally distributed. They never settle down. When you add some chemical, what happens? All the particles they will settle at the bottom. To undergo precipitation. This happen very commonly when you add some electrolyte, like a charged electrolyte is there. Example nothing but metal salts. All metals are nothing but silver salt, gold salt, whatever may be nothing but you can see all nothing but lyophobic colloidal solutions. This is based on their dispersion phase and dispersion medium interactions only. Okay, this one.